Okay, welcome guys. Here I am in my, what do we call this, terrace. Okay, it's a perfect weather to study mathematics. So it's raining, there's a light drizzle going on. Okay, and I'm going to tell you about the energy. Okay, now energy, we will be studying two kinds of energy. One is the kinetic energy, and its formula is going to be half mv square. That is the energy due to the motion of an object. Okay, so therefore this depends on the velocity. The kinetic energy depends on the velocity and the mass of an object. And then we shall be studying about the potential energy. That is the energy due to the position of an object. Now we shall not be going into a very detail of this work and energy as the physics people do, but I have to tell you the relationship between the work and the energy. Okay, as you know that energy is the tendency to do certain work. So if there is energy, only then we can do the work. So in a certain situation, when some work has been done, so that would actually mean that if a work has been done, then there should be a change in the energy of an object that we are talking about. Okay, now if for example there was an object, it was here and it had an initial velocity u, and when it reached here it had the velocity v. Okay, so here is the kinetic energy, which is going to be half mv square. Obviously energy depends on velocity, and here the energy would be half mu square. Now you want to see that what is the change in the energy. So that would be half mv square minus half mu square. That is the change in the energy. Okay, so I can call this delta E, the change in energy. Now if I take half m as common, that is v square minus u square. Now remember, the work is F into S, and you know that if it's the like if you take that the only force, there's just one force, so that would be ma. You remember our famous formula, our favorite formula, F equal to ma. So this F is changed with the ma times this S. Okay, and if I combine this with the equation 2as, that is v square minus u square. Okay, so now this as is going to be v square minus u square over 2. Okay, now let's look at, I'm moving from this to this over here. Now can I write this as m into v square minus u square over 2? Now can you see that they both have got, we have got the same, like, you know, expressions here. Now I'll be changing this v square minus u square over 2 with the as. Okay, so this becomes m a s, and now I'll be changing this ma with the f. Okay, so this is going to be s. So you see that this was change in the energy, the kinetic energy. So you see that the energy, the change in energy, that means it is some work has been done. So if there is a change in energy, so that means some work has been done. So that was, please look, you have to watch this video again and again, so that it gets clear to you that the change in energy represents the work, and that is why the energy has got the same unit as we have for the work. Now let me tell you how this energy is going to be related to the potential energy. Okay, now suppose you have an object, it is at a certain height over here, this is h over here. Okay, and now this has got some mass, and now that mass is changed into weight, and we call that mg. Okay, now when it is at this level, suppose it has the height h2 over here, and when it drops to this level here, the height is h1. Okay, so I can say that at this level the potential energy is going to be mgh2, and at this level the potential energy is going to be mgh1. So this h2 minus h1, that is going to be your height. Okay, now again work is F into S. Okay, and you people know that this weight is a force. So if I change this F with the weight over here, so this would become mg, that is the force that will be taking this under gravity from this position to this position, and this distance covered is, that is basically h. Okay, so this is going to be h. So you have seen that there is a relationship between either it is the kinetic energy or it is the potential energy. Okay, so that is the work done by the driving force. We have just one force over here, that isn't just using the driving force. Okay, so the work is, that is basically, and if you allow me to write it as mg times h2 minus h1, that is mg h2 minus mg h1. So now from this video you just have to remember one thing. No one will ask you to prove that how this work done is equal to the change in the energy. So just remember that the change in energy means some work has been done, and I have shown you both through the if you just started from here, from the kinetic energy point of view and from the potential energy point of view. Okay, so in the next video I'll be taking you into the details through some problems of this energy, so please stay tuned.